everyone! Today, we are going to explore statistical analysis using two important tools, analysis of variance or ANOVA and analysis of covariance, also known as ANOVA. These methods help us make sense of data. Let's begin by getting a grasp of ANOVA.
ANOVA is a statistical technique designed to assess whether there are any statistically significant differences between the means of three or more independent groups. This method has a fascinating history, dating back to the early 20th century when Sir Ronald A. Fisher developed it to analyze agricultural experiments. The basic idea is to partition the total variance in the data into different sources, allowing researchers to examine the variation between and within groups. The general formula for one-way analysis of variance is F equals MSB equals MSW, where F is the test statistic, MSB is the mean square between groups, MSW is the mean square within groups.
ANOVA is commonly used in various fields including experimental psychology, biology, and business to compare means and determine if there are any significant differences. So its primary purpose is to identify whether the observed differences between groups are due to generally effects or merely random chance.
Now, let's explore the analysis of covariance or ANOVA. ANOVA is an extension of ANOVA that incorporates the consideration of one or more continuous variables known as covariates. This method is particularly useful when there is a need to control for the effects of the covariates while examining group differences. The formula for ANOVA is an extension of ANOVA formula, including the covariates in a simple one-way ANOVA. However, this time, the inclusion of the covariates allows researchers to assess whether group differences persist after accounting for the effects of these covariates.
ANOVA is employed when there is suspicion that pre-existing differences in covariance may affect the dependent variable. It helps researchers to isolate and understand the impact of independent variable while controlling the effect of covariates.
To illustrate these concepts, let's consider a hypothetical scenario.
Imagine we're studying the effect of different teaching methods on students' performance in 3 classes. ANOVA could help us determine if there are significant differences in the mean scores among the classes. If we suspect that the students' prior knowledge could influence the results, ANOVA would allow us to control for this by including it as a covariate. Several statistical software packages can facilitate ANOVA and ANOVA, such as RPython with libraries, SciPy and stat models, and dedicated statistical software like SPSS and SAS.
In conclusion, ANOVA and ANOVA are invaluable tools for researchers and analysts, offering insight into group the differences while accounting for various factors. As you embark your statistical journey, remember that these methods empower you to unravel the hidden stories within your data.